Hi everyone, I'm Morgan Gautreau. I'm your professor for this introduction to artificial intelligence. So, in the previous lecture, we talk about artificial intelligence, the definition of artificial intelligence, the different applications that you can find in different fields, such as natural language processing, computer vision, sound recognition, reinforcement learning, etc. We saw that we have different kind of model that can solve problem in artificial intelligence. We saw that the only one was system experts. We extract information from experts how they solve a problem, and we try to code it, hard code it with rule in software. We have after fuzzy systems that try to incorporate the idea that feature are not Boolean 1 and 0, but in different states. And lastly, we saw the most interesting thing, machine learning. Okay, so machine learning is a very breakthrough in 1970. We saw that the idea is to learn rule not from an expert but from data directly. So we can extract a model but also extract new information, new incentive, new knowledge about the problem we try to solve. Okay. So machine learning is very important, but in 2012 we saw another buzzword we talk about a lot is deep learning. Okay, so now we see what is deep learning and what is deep learning versus machine learning. It's a new field, it's opposite thing, etc. We'll see just the slide after. So deep learning, in fact, is not a new way to code artificial intelligence. In fact, deep learning is a machine learning discipline that combines a method based on neural networks. In fact, deep learning is just another way to extract information from datasets. So we saw previously that we can have different learning algorithms that can extract information from datasets. We saw that we can use models that use tree approach, models that can use a distance approach, and models that can use linear approach. And deep learning is a learning algorithm that based on neural network. But we'll see after what is a neural network. To better understand artificial deep learning algorithm, we have to understand how our brain works, because neural network is an artificial how to say that, is a way to artificially create a brain, in fact. I will explain with an example, it will be clearer, I think. So, people see our brain and say that our intelligence come from our brain. So if we manage to record our brain artificially in informatics, we can recreate something intelligent or something that can solve problem in a way. So they try to understand how brain works. In fact, our brain are composed of billion and billion of neurons. Here is a biological neuron. A biological neuron will receive different information from our neuron, from other neuron in the brain. They will take all this information to create a new information and this neuron will pass this new information to other neuron. And so our brain is divided into different layers, different parts, different connectome that are specialized to treat different problems. Okay. So we create what we call an artificial neuron. Okay. So this artificial neuron will receive not different signal but different data. Okay. They will receive different data from other artificial neuron. It will stack this different data to create a new information. And this new information will be passed to other layer of neuron or another neuron. Okay. But as our brain and as in informatics, artificial neuron or biological neuron has not are not very performant. In fact, they can only treat very little little problem. So alone is not very intelligent. A neuron alone cannot do much thing. But it's when you combine neuron with billion and billion of other neurons that we create intelligence. Okay, and we'll do the same with artificial neuron. An artificial neuron alone is like an linear regression. It looks like a lot like a linear regression or logistic regression. But when we combine them together, we create what we call a neural network, and neural network is a base of deep learning that creates all the amazing products that we saw today, like autonomous car, self-driving car, we can unlock your phone with only your face. We can communicate with ChatGPT or other intelligence chatbots. You can create arts just by writing text. All of this new technology, new products came from neural network and deep learning. Okay, and they all came from the little neuron that alone are not better than a linear regression. Okay, so all neural network have the same architecture. You will have an input that receive information from data of our object of study that we want to solve. And here are output layer that return our outputs like the solution of our problem. For example, here we have in input layer we can have different information about a house we try to estimate, and here in output layer we can have the estimation of the house. Okay, so the information will pass from the input layer to here some what you call hidden layer. Each hidden layer will be a new representation of our first information. The idea is to create a new representation that is better suited to solve a problem. So here we'll have information. We'll here try to create a new feature that are better suited to solve a problem, and here we'll solve a problem to estimate the price of a house, or maybe I don't know if on a picture is a cat or a dog, or to create new art from text. Okay. And what's the difference between machine learning and deep learning, and what deep learning do that machine learning can't do? In machine learning, we saw that it's suited very, very good when we try to solve problem, structured data problems. So data that can't be stored in table. But when we try to solve problem with unstructured data like images, videos, text, sound, machine learning is not very interesting. They are not very performant because you have an extraction feature that we try to transform on unstructured data into tables. So by ourselves, we have to determine what is important in an image or sound, etc. And after, we have to make our classification. Here, to maybe in this example is in this picture, try to say if it's a car or not a car. Okay. And deep learning is different. Deep learning will give the unstructured data at the input of a deep learning model, and the deep learning model with itself may learn the feature extraction, so made the extractions, the better extraction, the extraction that will create a space that is the best space to solve our problem. And after, here at the end, a classification part that can solve our problem, is a card or not. So deep learning is the best suited algorithm to solve problem using unstructured data. It's for that from 2010 you have an explosion of application using sound, using picture, using videos, using text. And before 2010, very, very few products use this kind of data. Before 2010, every machine learning model you saw in production use only table data. Deep learning changed that. It's for that deep learning, everyone talk about deep learning today, is very, when you want when you have problem and you have unstructured data, always use deep learning. So here, if we take our neural network again and say, okay, I understand that neural network can extract information by itself, but how it does it? In fact, it's not more complicated than what we saw about machine learning. You have a model. At the beginning, every parameter of the model is set to random. Okay. We pass information in the input, for example, information about a house. We will everything is at random, so the output will be random. So we compute our error from this random, and the algorithm say, okay, what can I change in the parameter of the last layer? The next time that we saw this kind of information input, it will output an estimation of a house like more accurate. Now I say, okay, can I change? What can I change in the here in this hidden layer in this parameter, this hidden layer, that my output layer will output a better, a more accurate output. After, I will go back again and say, what can I change in my parameter information, parameter value, that help my network to estimate a better price for my house. And I do that for my input layer. In fact, I do that for every layer of my network. So it's not more complicated that machine learning algorithm, but here we have to do that for every layer in our neural network. Okay, so when we do that for a lot of observation and multiple time by observation in long time, we'll have a model that can predict new price for houses with data that we don't know, in fact, the price of the houses. So when I have accurate model, I can use to every new data that we have. Deep learning, here we have the number of observations that we have, here the performance of the algorithm. If I have very few data, in fact, deep learning will not have better performance than traditional machine learning algorithm. So when you have few data, you need to use traditional machine learning. If you have a lot of data, you can use a shallow neural network. You will have better performance. That's traditional machine learning. If you have more data, you can use deeper architecture for your neural network. So, when I say deeper, I say with more hidden layer. And if I have a ton of data, I can build a deeper and deeper architecture for my deep learning. And deeper the architecture is, the better the performance will be. So now we are in the area of big data. So you have a lot of data, a ton of data. It's for that now we have deep learning that are widely used. Deep learning, in fact, are known from 1980. It's old algorithm, but we didn't have the enough computing power and enough data to train such algorithm. So now we have a lot of computing data thanks to GPU and computing power. We have a lot of computing power thanks to GPU, and a lot of data thanks to big data area. So we are in a time that is we can use very an efficient way. We can use deep learning in a very efficient way. Okay, but most of the time when we use deep learning in a supervised way. Okay, like we say, supervised learning is when you have explanatory variable in one hand and you have target variable in other hand. So you have labeled data. But labeled data, you have to label our data most of the time. So you have to pay people to label our data, or I don't know, make programs that label your data before training your algorithm, and it can be very expensive to do that, because when I say a lot of data to train an algorithm, it can take, I don't know, million and thousand million images to train some of the best classification model. So yeah, like I say, ton of data is really ton of data. Like I said before, 2010, people used for computer vision classical machine learning or thing like that. When deep learning arrived, there is a significant drop here in error. Here is computer vision challenge. Is imagined competition. Is like you have 1 million images, and you have to create an algorithm that's achieved to answer to the question what is in this image, and you have 1,000 classes, and the model have to find which in which category put this image. And you saw that with deep learning you decrease the top error very, very quickly, even that a human now in this kind of competition have make more error to solve this problem than computer. So in the world now, you have not a lot of area, or the computer is better than human, but you have some area that computer with can achieve more performance than human, and is lot of time is in computer vision because we have a ton of example. Okay. So, like I say, deep learning can use unstructured data, and in the same way open new possibility to use sound in your product, videos, images, and text. Okay? Because all of this kind of data are unstructured data. Okay? And for each kind of data, you will have a different deep learning architecture to solve this data. So with structured data, like data that can be stored in a table, you can use deep neural network. So like I said, deep structured data can be I don't know, information about a house, and you have to predict the price of the house. Is structured data. You have information about, I don't know, different value from a person, a medical exam, and you have to predict if this person has a certain disease. Okay. If you want to work with computer vision, okay, you will use what we call an architecture called convolutional neural network, or CNN, for C for convolutional, N for neural, and N for network. Here the idea is that convolutional neural network will extract some information about images, and to ultimately find the best way to transform this image into a vector, and after use this vector to solve the problem of classification. Here, the problem of classification, we have an image, and we have to predict if on this image we have a dog, a cat, a deer, or a lion. And we have time series. We can use recurrent neural network or RNN, R for recurrent, N for neural, and N for network. Here we can work with time series. For example, I don't know, try to predict the price of stock during time, or temperature during time, even text. If you want to solve, I don't know, natural language processing, for example, problem, you want to determine the sentiments in a sentence, you can use neural network most of the time. Even if today in some application we'll use also transformers that we will see in the lecture further. Okay? The idea is always the same. If we use a recurrent neural network, computer neural network, convolutional neural network, or deep neural network, we have always the same structure. We have here our entry data. We'll have a part that is built to extract information from your entry data, input data, and a part to make the classification until we are in the output of our data, of our structure, of our model. Okay? And the idea is, like we saw, that unstructured data are not in a form that can be used easily per program, because we cannot fit that into a table. Okay? It's not a vector, it's more complicated than that. To be summarized, this extraction characteristic part, the main goal is to transform unstructured data into a vector, because in a vector can be easily used to, I don't know, make some mathematical property and mathematical thing, mathematical model to solve the problem. So the idea is to transform this unstructured data into a vector, and this back to take this vector to make a prediction. Okay. And the idea is not to transform this unstructured data into a random vector, but the best form of the vector, the best space possible to solve the problem that we want to solve. For example, here, to know if it's a cat or a dog. Okay? So, in my previous example, it was for image, but the idea is to make the same for language, for vision, or for sound. We transform here this into a vector, and like that, we can use to make each to solve every problem we want, even unsupervised, self-supervised, supervised, reinforcement learning. We can do what we want. The idea is to transform this unstructured data into vector to solve a problem, or to create a space that encodes the information from the data, to make what we call multimodal machine learning. Multimodal machine learning is a way to use different kind of modality. Modality, for example, is language is a modality, vision is a modality, sound is a modality, and it's very popular now to try to work with multimodal machine learning. When you saw, I don't know, Daily 3 or Midjourney, you give text. The text is transformed to a vectorial representation, and from this vectorial representation, the idea is to extract an image. So when you achieve to transform a modality into vector space, you can do what you want with the vector, and solve what problematic you want to vector. I'll talk a bit about multimodal modality because now it's very popular, but it starts from some research from 1980 with audio-visual speech recognition, and after with content-based retrieval, affect emotion recognition. but it's very they have some research, but it's from like this point about 2012, 13, that we have the really birth of language and research. And from that, in 5 years, and now we are in 2023, you have a lot of different way to and different application of multimodal research, and this different research lead now to what the way to use ChatGPT, DALL-E 3, Midjourney, Bard, Claude, and all of these different applications. And the idea, like we say, is always the same: transform information into transform unstructured data into a vector representation. Okay. And when you have in this when this vector encapsulates the information of this unstructured data, there are interesting properties. For example, if you are here the vector representation of king, from man, from queen, from woman, and from queen, the vectorial representation of king are at the same distance of queen that the man from woman. So here the distance is a man because it encapsulates the thing that the difference between man and woman is the same difference that king and queen. It's just the distance is equivalent to the difference of gender. For example, we have the same thing with verb tense, with, for example, walking and walked, swimming and swam. And you can do that with lots of things. For example, here from here country, and here for the capital of the country: Spain, Madrid, Italy, Rome, Germany, Berlin, Turkey, Ankara, Russia, Moscow, Canada, Ottawa, Japan, Tokyo, Vietnam, Hanoi, China, Beijing. Okay? And you can, with that, do a lot of things very interesting. For example, you use CNN to transform this, like we saw, because CNN is how to transform an image to a vector. And after with this vector, you can use the RNN. You saw that to deal with temporal series, okay? To transform this vector into a caption of this image. For example, here you have an image, and the model will output a group of people shopping at an outdoor market. There are many vegetables at the fruit stand. Okay. Another a very example that I think a little funny. A man, a group of research train an algorithm that came from an image, create a story. So you have this image, and you have here a little story that's are totally imagined by this image. So yeah, it's very interesting. All the information that can be stored into an image. After another group of research trained an algorithm from image to generate some tag from the image. For example, here I have an image and generated a dog, cat, pet, kitten, puppy, etc. Here some image, some tag, and from tag to create images. Okay, water, red, sunset, etc., etc. What is very cool for multimodal arithmetic is quite the same from embedding, for word embedding, that if you take this image, you retrieve the vectorial representation of day, you add your vectorial representation of night, and we try to search the nearest representation of image, and we have that. So he understands that we are not anymore in day, but we are in night. So he gives some monuments night in the night. Here, if we have a plane, say, okay, mine makes the difference between the information of flying plus sailing, and we get the boat. So he understands that boats and fly are transports, even if nobody tells the model this kind of thing. He understands by itself. For example, here we have kitten in ball, minus ball plus box, and we have cats in box. So he understands that that is a cat. So we have to find other images that are cats also. Here, as I say, minus box plus ball, and it's not a ball, but he understands that this looks like a ball. And here is not a cat, but it looks like a ball. So yeah, we can have sometimes mistakes, but the idea is the model learns a lot of things by itself. What is very interesting, that it's the same for sound also. Like I say, sound is not a lot let's use because we don't have much data. But here, what they did, they take sound and they try by sound to detect some object detect some object with the sound, and hear some scene, okay, just with sound. So here we have video, but only sound is given to the model. And here I click, so I don't think you have the sound, but you have a video. And here the website try to the model try to predict where we are and which what kind of objects are in the scene. So you have different example. Here we are I think in a car or a plane that's in a plane that's take off, and okay, he says that he tried to say a wing, airliner, sky, ocean, runway. So yeah, he achieved to extract information from the scene just using sound. So it's very interesting. And this kind of multimodal, like I said before, this kind of multimodal work ultimately gives this kind of thing. You just write a sentence, a kid and a dog staring at the sky, that transforms this sentence into a text embedding, and from transform into an image embedding that decode into this image. And this image was it's unique. Nobody created this image before. Just this sentence achieved to create this kind of image. It's very interesting here. But the goal is not to, with GPT, with daily, is not just to create image. So create image is a cool application, but the very what is hiding behind is the ability to give computer a better understanding of our world. If a computer can create this kind of image just with a sentence, he deeply understand what's the sense behind this image, this text. Okay, for ChatGPT is the same. I say, okay, write hello world in Python. Make a text embedding, a decoder, and hop, he prints hello world. So yeah, he understands what is Python. It's not a snake. It's a programmation language, and so it's what we have behind ChatGPT, behind Daily 3, behind all the interesting topic and application we saw. Here the idea is the main goal is to give computer a better understanding of our world and of us. Okay. And for company, what's very interesting, because I talk about researcher just before, but in company, the idea to study multimodal information and to use deep learning to extract all the value or the information from the data is to extract the more information possible from your customer. So information from what they talk about in social media, in your CRM, when they interact with your website to bill or ordering something. About the demographic, about when they call your service center, when they use your application, and what's and the location. Okay, you can mix everything to create new application to better understand your customer and to push the right offer at the right moment with the right product to make a sale. So we can do a lot of very good things today, but we have still open challenge. Go beyond text and image or video, because it's most used, like I say, most used modality. But in fact, it's most used because it's where we have the most data. But we have to go beyond that. Make translation also beyond the descriptive text and image. Create fully multimodal generation, so cross-modal coherence within modality consistency. So model evaluation, human and automatic, and ethical console of generative models, because with ChatGPT, Daily, etc., we can make generative, but it's very biased. There are a lot of bias from where they were trained. For example, here we have Barack Obama. It's a noisy image. We create an algorithm to try to denoise this image, and we get a person that is white, mostly. So you see that there is some bias to this algorithm. For example, that was in ChatGPT 2, but ChatGPT 4, it's the same. From some time, you give a prompt, some information, and it reveals some telephone, some phone numbers or email address that are very private, and so there is some problem. And here, for some prompt from some generated texting, it reveals that we have some bias and from some sexism of the understanding of the world from this algorithm. So for deep learning, you have some pros and some cons. We have pros, that is a high performance model. We can achieve the higher performance using deep learning if we have enough data. It makes the automatic feature selection itself, so it can work very, very easily with unstructured data. But we have cons. It's a black box. So whereas in machine learning expert system, fuzzy model, we can we know for sure when the algorithm take a decision, why it take a decision. For deep learning, we know that it has high performance, but we can't know why it take a decision. It's too complex for that. And we have lots of common sense. It can be very effective, very performant, or very hard problem, but can have very poor performance sometime on very easy solvable for easy exams that a human can solve in 1 second. And to train this kind of algorithm, you need a large amount of data, sometimes millions of observation, and it's very complex and time consuming for the algorithm to learn information and to be trained. Okay? So it's finished for this lecture. I hope you are better understanding what is deep learning and the difference between deep learning and machine learning. See you in the next lecture to better to discover the different tools that you can use to solve a problem with machine learning and deep learning.